So we're figuring out this positive charge right here in the middle. I've got a couple of sensors here. All we want to do is figure out what the values are by clicking this button. Bam! Notice this is a positive charge. And so the vectors pointing out here are representing the electrical field. And of course, I just got a couple of values. Let's jot these down. One thing we can notice is that these corners are much weaker than these edges, and that's because, again, this is supposed to be a circle. If it was a circle, they would all be equal, but it's not. Yo, look at that. That's kind of cool. Put a negative value and look what happens. Notice how the forces come inward now instead of outward. That's pretty cool. So we're going to be determining the value at 10 different points as this moves out further from the center. So we're going to try to see what happens as this goes further and further out. So we can see from this graph that the slope is decreasing, and it's decreasing at this exactly negative 1.98, but it's really supposed to be negative 2. So anyway, that's basically saying that it's inversely proportional to the distance squared. So now we're arranging some positive charges in this way, and it turns out that there's a force in between them, somewhat like this. So when we take those away and we just see 1, we could see this is E1 at the moment. As we take away that charge, we can see the other charge, charge 2, has this electric field pointing that direction. So we have these two positive charges that combine together create this electric field pointing in this direction. And we were supposed to calculate if we add a positive charge somewhere around over here somewhere, we're going to try to get this to be negative, or to equal to 0. Just equal out like that. And this should be pretty close to where we found the coordinates of our new charge. Now we can see that if we add a negative charge to this assortment, we will be able to find a net zero of around negative 30 and then negative 90. So